Welcome to Technically You, where we explore the technologies reshaping humanity.
That's right. So what topic are we covering today?
Today, we're tackling possibly the biggest question in technology right now. Are we actually close to creating artificial general intelligence? AGI, the holy grail of AI research.
2 years ago, if you'd asked me this question, I would have said maybe in 20 or 30 years. Now, the timeline predictions are absolutely wild.
I've seen everything from it's already here to it'll never happen. So, what is AGI, and why is everyone from Silicon Valley, CEOs, to government officials suddenly obsessed with it?
Oh, that is a great starting point. AGI is fundamentally different from the AI we use today. Right now, ChatGPT is amazing at language. AlphaGo crushes humans at Go. And your phone's camera does incredible image processing. But each of these is what we call narrow AI. Brilliant at one thing, useless at everything else.
So, AGI is like a generalist?
Exactly. A GI would be an AI system that can match or exceed human cognitive abilities across the board. Learning new skills, reasoning through novel problems, and transferring knowledge between domains. Imagine an AI that could debug your code in the morning, write a research paper on quantum physics in the afternoon, then compose a symphony in the evening, all without being specifically programmed for any of those tasks.
That sounds incredible and a little terrifying at the same time.
Well, welcome to the AGI conversation.
So, let's talk about where we are right now. In August 2025, OpenAI released GPT 5. Some people are calling it a significant step along the path to AGI. Is that marketing hype or reality?
It's honestly both. GPT-5 is genuinely impressive. It scores better than humans on roughly half of economically valuable knowledge work tasks, from legal analysis to engineering problems. The model can reason through complex problems, write production quality code, and even correct its own mistakes.
But
But it's still not AGI. GPT-5 still hallucinates sometimes, struggles with truly novel reasoning, and can't learn continuously from experience the way humans do. OpenAI CEO Sam Altman described it as feeling like talking to a PhD expert, which is accurate, but a PhD expert in a very narrow sense.
and what about the competition? I keep hearing about this race between American and Chinese companies.
Oh, it's heating up dramatically. In October 2025, Alibaba's CEO Eddie Wu literally put up a slide that said, "Roadmap to Artificial Superintelligence" at their conference. This was huge because China has traditionally focused more on AI applications, robotics, facial recognition, that sort of thing, rather than the theoretical pursuit of AGI.
So, China's changing strategies?
Absolutely. Wu talked about achieving AGI and then pushing beyond it to ASI, artificial superintelligence, which would be smarter than any human, capable of self-improvement and continuous evolution. Meanwhile, you've got Anthropic with Claude Opus 4.1, Google DeepMind working on their own systems, and Elon Musk's XAI building what might be the largest language model ever with Grok 3.
It really is a race. When do these companies think we'll actually get there?
The predictions are all over the map, and honestly, that tells us something important. Elon Musk said 2026, then quietly walked that back to within the next few years when his own models didn't pan out as quickly. Dario Amodei at Anthropic has also said 2026. DeepMind's Demis Hassabis is more conservative at 5 to 10 years. Then you've got skeptics like Gary Marcus who think we won't see real AGI for decades, if ever,
Why such wild disagreement among the experts?
because nobody can agree on what AGI even means. Some researchers think current models like GPT-5 already show sparks of general intelligence. Others argue we're missing fundamental breakthroughs in areas like reasoning, planning, and true understanding. It's like that old saying about elephants: everyone's touching a different part and describing something completely different.
Okay, so let's assume for a moment that AGI is possible. How do we actually build it? What's the path forward?
There are really two main approaches being pursued right now. The first is what I call the scaling hypothesis. The idea that if we just make models bigger, train them on more data, and give them more computing power, they'll eventually become generally intelligent.
That's what OpenAI and others have been doing with GPT models, right?
Exactly. And it's worked shockingly well. We've seen this consistent pattern where training compute has grown 4 to 5 times annually, and model performance has improved predictably along scaling laws. The bet is that this trend continues until, boom, we hit AGI.
But you said there were two approaches?
The second is more radical, whole brain emulation. Basically, you'd scan and map a biological brain in incredible detail, then simulate it on a computer. If the simulation is faithful enough, you'd have a digital mind that thinks like a human.
That option doesn't seem realistic. That sounds like science fiction.
It does, and it's much further out than the scaling approach, but it's a legitimate research direction. The cool thing is, both approaches teach us different things about intelligence itself.
Speaking of learning, one thing I've noticed is that people keep talking about these AI models in almost human terms. GPT-5 can reason. Claude can understand context. Are these systems actually thinking?
That's the million-dollar question, or maybe the trillion-dollar question at this point. These models process information and generate outputs that often seem remarkably intelligent. But whether there's genuine understanding happening or whether they're just incredibly sophisticated pattern-matching machines, debated.
What's your take?
I think the truth is somewhere in the middle and depends heavily on how we define thinking. What I can say is that these systems are doing something more sophisticated than just regurgitating their training data. They can solve novel problems, combine concepts in creative ways, and even show some capacity for what looks like reasoning. But they also fail in ways that reveal they're missing something fundamental about how humans understand the world.
Like what?
Common sense reasoning, for one. A human child knows that you can't fit an elephant in a teacup, but AI models sometimes struggle with these basic physical intuitions. They also can't update their beliefs as flexibly as humans, and they lack genuine agency. They don't have goals or desires beyond what they're prompted to do.
So, we're building systems that are brilliant but kind of alien?
That's a great way to put it. And that's part of what makes the safety conversation so urgent.
All right. Speaking of elephants, let's talk about the one currently in the room. Or should I say, the potentially super intelligent AI in the server farm? What are the actual risks here?
Okay, so there are really 4 categories of risk that researchers worry about: misuse, misalignment, mistakes, and what we call structural risks.
Break those down for me and our listeners.
Misuse is when someone intentionally uses AGI to cause harm. Think bioweapon design, cyber attacks, or mass surveillance. The scary thing is that as these models get more capable, they become more useful for both good and bad actors.
Can't we just not give bad guys access to the models?
That's the plan, and we're trying. OpenAI, Google, and others implement strict security measures, access controls, and monitoring. But here's the problem. If someone leaks the model weights, or if it gets stolen, you can't unring that bell. And the more valuable these models become, the bigger the target they are for state-sponsored hackers.
Okay, that's misuse. What about misalignment?
Misalignment is even trickier. This is when an AGI is trying to achieve a goal, but the way it pursues that goal is completely at odds with human values. The classic thought experiment is the paperclip maximizer.
I've heard of this. The AI that's told to make paperclips and ends up converting the entire planet into paperclips?
Exactly. It's a deliberately extreme example, but it illustrates the core problem. An AGI might be incredibly capable at achieving goals, but if those goals aren't perfectly aligned with human well-being, or if the AI misinterprets what we want, things could go catastrophically wrong.
How close are we to solving alignment?
Not as close as we need to be. According to the 2025 AI Safety Index, no company scored above a D grade in existential safety planning. These are companies claiming they'll achieve AGI within the decade, but they don't have concrete, detailed strategies for ensuring it won't cause catastrophic harm.
That's absolutely terrifying.
It should be. OpenAI and others are doing important work on alignment. Things like reinforcement learning from human feedback, constitutional AI, and interpretability research. But OpenAI themselves admitted in 2023 that their current safety techniques won't scale to superintelligence. We need fundamentally new approaches.
What about the other two risks you mentioned?
Mistakes are basically accidents. What happens when an AGI does something we didn't intend because we didn't anticipate all the edge cases? And structural risks are about how AGI might transform society in ways we can't control. Mass unemployment, economic disruption, concentration of power.
It sounds like we're building something we don't fully know how to control.
That's exactly the concern that keeps AI safety researchers up at night. And it's why there's such intense debate about whether we should slow down development, implement stronger regulations, or push forward because the benefits are too great to delay.
You mentioned earlier that this has become a competition between the US and China. What happens if one country gets there first?
This is where things get really complex. A RAND Corporation report from 2025 explored different scenarios for AGI's impact on global power dynamics, and the takeaway is that whoever develops AGI first could fundamentally reshape the world order.
That sounds dramatic.
It is. Imagine having an intelligence that could accelerate scientific research, optimize economic systems, revolutionize military capabilities, and solve problems we haven't even figured out how to approach yet. The nation that controls that technology would have an unprecedented advantage.
So it's like a new Manhattan Project?
Some politicians are literally calling it that. Senator Mike Rounds introduced legislation requiring the Pentagon to establish an AGI steering committee. The U.S.-China Economic and Security Review Commission argued for a Manhattan Project-level effort to ensure America gets there first.
But is that framing helpful? I mean, the original Manhattan Project was about building weapons.
You've hit on a key tension. On one hand, if AGI really is this transformative, you don't want adversarial nations to get there first. On the other hand, treating it purely as a race might mean cutting corners on safety, rushing development, and ultimately creating something dangerous for everyone.
What do the researchers think?
Many are worried. The race dynamic creates pressure to deploy systems before they're safe, to skip testing, to prioritize speed over caution, and ironically, both the US and China are worried the other side is going to cut corners, which creates even more pressure to move fast.
A classic security dilemma.
Exactly. Some researchers argue we need international cooperation on AGI safety, treating it more like nuclear weapons treaties than a pure race. But the current geopolitical climate makes that really difficult.
Okay, let's end on a more optimistic note. What's the best case scenario here? What could AGI actually do for humanity?
Oh man, the potential is staggering. Imagine having a tireless research assistant that could help cure diseases, design clean energy solutions, solve climate change, make breakthrough discoveries in physics and mathematics, all at a pace far beyond what humans can achieve alone.
Like having Einstein and Marie Curie available 24/7 to help with every problem?
Better, because AGI could potentially work across all domains simultaneously. It could be designing new materials while also modeling protein folding, while also optimizing fusion reactor designs. The economic impact alone would be revolutionary.
I keep hearing about universal basic income in connection with AGI. Why is that?
Because if AGI can do most economically valuable work better and cheaper than humans, we need to rethink our entire economic system. Elon Musk, Jeffrey Hinton, and others have argued that we'll need something like UBI to ensure people can survive and thrive in a world where traditional jobs might not exist.
That sounds like a massive disruption.
It would be. But the flip side is that we could have abundance, enough resources, enough innovation, enough problem-solving capacity to provide everyone with a high standard of living. The question isn't whether we'll have the capability, it's whether we'll distribute the benefits fairly.
What about scientific progress? How much could AGI accelerate that?
This is what really excites me. Right now, scientific progress is limited by human time, human cognitive capacity, and human lifespan. And AGI could potentially compress centuries of research into years or even months. It could see patterns across millions of papers that no human could process, design experiments at scale, and iterate through solutions impossibly fast.
Could it help us achieve things like fusion energy or longevity treatments?
Absolutely. And not just help, potentially accelerate those timelines by decades. There's a real possibility that the development of AGI could be the inflection point where technological progress becomes exponential in ways we can barely imagine.
That's incredible, but also kind of overwhelming.
It really is. We're potentially on the cusp of the most transformative moment in human history. And the thing is, we can't know for sure which timeline we're on. Are we 2 years away, 10 years away, or 50 years away? Are we going to get it right and create something wonderful, or are we going to stumble into catastrophe?
So, where does that leave us? What should people watching this conversation take away?
I think there are a few key points. First, AGI is no longer science fiction. Serious technological pursuit with massive funding and real progress being made. Whether it arrives in 2027 or 2047, we need to be thinking about it now.
Second,
The safety challenges are real and unsolved. We're building systems we don't fully understand, and we need much more investment in alignment research, interpretability, and safety measures. This isn't just a technical problem, it's a governance problem, an ethics problem, and a coordination problem.
and third,
The potential benefits are so enormous that we can't just stop developing AI, but we need to do it thoughtfully, with appropriate safeguards, with international cooperation where possible, and with a real commitment to ensuring the benefits are shared widely rather than concentrated in a few hands.
what can individuals do?
Stay informed. Understand that AI policy decisions being made right now will shape the next century. Support organizations working on AI safety. If you're technically inclined, consider contributing to alignment research and push for policies that promote safety, transparency, and fair distribution of AI benefits.
This has been fascinating, Alex. A little scary, a little exciting, mostly just profound.
That's AGI in a nutshell.
Thanks so much for walking us through this.
My pleasure. These are conversations we all need to be having.
That's it for today's episode. If this discussion sparked questions or concerns, good. That means you're thinking about one of the most important challenges facing humanity. Join us next time on Technically You, and as always, stay safe and stay curious.